Now, 1.7, transformation of functions. This section is a very, very important foundation for your chapter 4, trigonometric functions. So if you feel hard and try to give up for this section, then I think you better just drop from this class right now. Okay, so but I will do my best to make sure you feel it's not too hard if you learn very little step every time. So in the end, you are going to learn the whole pictures. That is pretty hard, but you learn every little steps for the graph. Then every time you learn, I hope you don't feel too hard. Okay, so if after the class, if you have questions, then you may ask after the video. If you still have some questions, you may ask me during the class time online. Now, first, I think most of you probably still remember from algebra 2, you learn these two. These two actually are the same formulas. We call transformation. If you plus k on both sides, then you have the next one. Same thing, right? Same thing. Okay, let me erase it. So these two are the same thing. And I would like to go through example 1 first, and then we can go back to talk about the formulas. Now, transformation means if you have a parent function, so say you have a parent function, on algebra 2, we learn a parent function, for example, f of x equals to x squared. And then we find the vertex we call hk. So how about if we try to shift the vertex to somewhere else? Okay, hk. And for the parent function, yes, the parent function, the vertex need to be 0, 0. And then we try to shift to a new location for the new vertex. Here, we call hk. Then what's the function? The new function will be minus h plus k. So pretty soon we are going to go over example 1. You will feel each part is pretty easy actually, but when we mix h and k together, you have more questions. So I will go back to talk about more detailed concerns for how to use this formula again. But let's try example 1 first. So example 1, number 1, part A. Part A, if you have a parent function and this new function, how to graph? If your parent function is something like that, this is f of x, and your new function asks you to plus c. So what's plus c? Means the y value plus c. So if this is the function value y, and all the y value plus c means you try to shift everything up. So you are going to have something like that. Shift up when c is positive. You plus c means all the y value plus c. So this is y plus c. All the y value plus c. So the whole graph will be shift up. Let's kind of obvious. So this is a vertical shift of F, C units up when C is positive. Now, if you have part B, you minus C, then you shift down C steps. So number 1, A and B, I think I consider it's not too hard. So the whole graph will be vertical shift of C units down. Right? I think it's this one. C units down. Now the hard part is C and D. And after you understand the C and the D, then you will have more question comes up. But let's talk about part C first. If you have parent function f of x, okay, so you say this is your salary and x hour you work. So if you work x hour and you pay your boss your company will pay you y dollars. So x hours you earn y dollars. Now what happens if you have f x plus c? So if you work x hours, your boss consider you work x plus c hours. So for example, if c equals to 2, so it means if you work for x hours and your boss consider you work for x plus 2, so you work you earn more hours than you work, right? So this is your new income. Okay, so originally you need to work x hour to earn y dollars. Right now, in order to earn the same y dollars, you may work this hours. So this hour is the idea of when you see plus, actually you work this. So again, I want to emphasize one more time. When you have plus C, means you work these hours. So let me erase those marks. Too many marks here. So not like a question A and the question B. Question A and the question B, when you see plus, when you have plus C, you goes up. You push the whole graph up. And when you have minus C, you push down the whole graph. Okay, so depends on plus, you go up. Minus, you go down. Now, question C is a little different. When you see plus, you work this. When you have minus C, you work more. For example, originally your boss pay you for how many hours you work. But if you change your manager, and your manager is another very nice manager, he said, okay, if you work for 5 hours, no matter how many hours, if you work for X hours, I may take away 5 hours from your work hour. So I will pay you 5 hours less. So Okay. So it means if your boss pay you 5 hour days, then do you have to work harder? Yes. For example, if you want to save money, save your income to buy a new car, then do you have to work more hours in order to save the same amount of money? So when your C is plus 2x or the C is plus 2y, it makes different. So when C related to x or C is plus for the y, this is y. So this y minus C, this is y plus C. But this is x plus C. X plus C actually, when x plus, you need to work this out. When x minus C, you need to work more hours in order to earn the same y value. So this is how I explain to you. But if we go back to algebra, then we don't want to always think about the reason, and then we do our test. So when we, as long as you understand what the plus minus means, so let's go back to the formula here. Let me erase all the marks. So let's start all over one more time. Do you agree with the formula? Okay. So if the parent's function is function of f, now on the test, I would like you to memorize very easy, simple formula is if you have a function y, plus k means push up or down, depends on k is positive or negative. Okay? And the plus k means push up, minus k means push down. But when we talk about the number nearby x, means your boss is going to take away h hours. So you have to work harder if h is positive. So here, let me change color. So if h is positive, sorry, let me write down this one in order not to confuse you. If x is positive, let me erase this. Okay. So if k is negative here. Okay. Now we go to h. When h is positive, we work this out. Okay, your x will be smaller than the original hour x. And when h is less than 0, less than 0 like a negative 3. So take away negative 3 means plus 3, right? So when you work for x hours, your boss was so nice to plus 3 hours for you. So in order to save the same amount of money, you don't need to work so hard. You can work 3 hours less. So it means if h is less than 0, then if x is positive, then your x need to be greater, right? Okay. And then when h is less than 0, then you push your graph to the left hand side because you don't need to work so hard. So means when you push the graph to right hand side means your x need to be greater. You need to work harder in order to earn the same original amount you need to save. Now, it comes with the form, the concern of the students. Say most students will say, okay, part A, B, and the C, D is easy to understand. And when we use the formula, if we don't think too much, we learned this formula before, right? HK, the number you take away is H. The number you plus is K. So if we have quadratic function, then the new vertex will be H and the K. But why you take away H and the plus K? Why one is plus, one is minus? Think about that. Okay, one more time is, let me erase everything and make the formula very easy to understand. I talked about this algebraically earlier today, right? So these two functions actually are the same. If you take away k on both sides, what do you have? These two cancel out. This two is gone. And you have this one. What do you have? Same thing. Okay? So actually the original formula, take away h, take away k. Same formula. Okay? So when you take away h, take away k, actually you shift from 0, 0 to hk. But how come the formula we have take away h and plus k? Because when you talk about function, you need to solve for y equals to something, something, something. So that's why the formula we memorize. So the original logical formula, if you memorize the number one formula, makes sense, right? X take away h, y take away k. So the new vertex will be hk, obvious. But we solve for y to memorize the formula. So if you solve for y to memorize the formula, then you have this formula. So means you minus h plus k. If you minus h plus k for the solve for y formula, then you have the new vertex also hk. So these two are the same thing. Keep in mind. So from the homework question number 1 ABCD, there's a detailed explanation for you. You may watch video again and again till you understand, or you still have question you ask me in the class time. But on the real situation for the more complicated work or on the test, you would like to memorize formula to do the test, which you memorize this by this formula, because most time we have y equals to a function. We don't have this form. We don't have this form. Okay. So when you have a function y equals to, then for the x, the number take away is the new vertex. And for the whole y value, the number you plus is the new vertex. You need to memorize that. Then next we go to number 2. So number 2, what's the parents function you want to first? Parents function. Parents function y equals to x squared. So you can graph y equals to x squared, we learned that. And the original is the vertex. Now plus c, c is the k, right? K equal to c. And then x take away whatever. No, you had the same x, okay? So you didn't have new left right shifting, but you do shift the um, graph up or down. And there are three different types of the C you may want to graph. So when C is -3, you push down. When C is -1, you push down a little bit, and 1 you push up. 2 you push up 2. But this question is harder to graph. Why is that? Let me erase this one. So all you understand, you keep in mind to understand. So I will just save the parents graph here. Now shift up, down, left, right. Not too hard. But you want to pay attention on this is a step function. So you have 1 and 2. When x is less than 0, you keep the same graph but push up c steps. Depends on what's c, okay? So let's make it easier for the positive 2. So we just graph when c equals 2 first. So that's 2. So you keep the same graph. And when x is positive on the right hand side, follow order of operations. Order operations, you multiply negative sign first. So for you multiply with negative sign, so positive become negative. Yes? And then you push up 2 steps. So let me have final. So this one you push up, become this. So this is c equals to 2. Okay? And then when it's 1, you do the same thing, but c equal to 1, right? That's the same thing. And when c is -1, you need to push down. -1. You follow the same graph. Let me do it later. Not good. Like that. Probably a little bit. And c is -3. -3, something like that. Okay. So that's the graph I will choose, which is which one. So I would like you to hand graph and then choose. That will be easier. Okay. So if you take a look, the whole thing will push up or down depends on C. But on the original graph, it is supposed to be a quadratic function. But when x is positive, you need to have a negative x squared. Okay. So when the whole x squared become negative, means the original y become negative y, right? So up down. It's up down. Now part B. So you want to compare the question from the previous question. Previous question, I say our negative sign is for y. Okay, the negative sign is for y. or you say for x squared, not for x. But this time, it's also for x squared, I thought. Okay, so if you have a question for this type, fx equals to negative x plus c squared is different from fx equals to negative x plus c squared. Okay, when x is for negative for the x or negative for the whole y. This is negative x, this is negative y. Okay, so that's different. Now, I saw the part B probably is different from the previous question, but looks like a similar question. Okay, negative for the whole parentheses. So it means negative for the y. So still up down. Right? I think this is wrong. Okay, so still up down. Yeah, up down. There's no left right. So it's up down, right? It's up down here. Now this goes to oh. So I think we better graph by ourselves first, and then we can choose here. Okay. So the original graph, let's graph lightly x plus c. So here when you have plus c, oh, okay. The previous question we plus c for the y value. So you have push up down. But when you have plus c to the, so that's nothing wrong. Okay, that's nothing wrong. When you have plus c for the x value, when you have plus c for the x value, then you have to shift. Okay, this also shift. This is shift left right. Depends on c may equal -3, -2, 1, and 2. Depends on the c value, but it's push shift left right. Okay. Now the original function, the parent function y equals to x squared, and we don't plus minus x squared to like this. Okay. So right now the c is plus inside, so it means your bus is going to add 3 more hours for you or take away 3 more hours from you. It make a big difference. But the original graph, same thing here. Okay, and that's 0, 0. Okay. Now, same thing I want to start from 2. If your bus is so nice, plus 2 for you, plus 2 hours for you. So in order to earn the same graph, you don't need to work too hard. So it means originally, if you don't work, you earn nothing. That's called origin, right? You don't work, you earn nothing. But your bus plus 2 for you, x plus 2. It means if you don't work, your boss consider you work for 2 hours. So nice. Right? So if you work for 0 hours, your graph will be looks like you work for 2 hours. Right? Looks like you work for 2 hours. And if you we can never say we work for negative 2 hours, but pretend if we can work for negative 2 hours, then your boss consider you work for 0 hours, right? So your vertex actually is here. Will be like that. Now, when x is negative, we choose number 1. Okay, so when x is negative, we choose number 1. So we erase. Oh, sorry. When x is negative, and then we circle, not equal. We choose this graph. And so let me have this dotted. That's better, right? When x is greater or equal to 0, we have negative whole thing. So this one goes to negative. Yes? Okay. So let me see. Any graph looks like this. Any graph looks like that. Let me see which one. Uh, right. Negative. When x is positive, we have, yeah. So the right choice will be which one? And this is 2, right? And then we have, when we have, this is 2, this c equals to 2. Let me write down. C equals to 2. And how about c equals to 1? This is c equal to, how about c equal to 1 will be here. C equal to 1 will be here. And c equals to negative 2. C equals negative 2. I need to choose other color, otherwise everything mixed together. So when c equals negative 2 means your bus take away 2 hours, so you have to work harder. So if you work harder, it becomes plus 2, right? So something like that. When you have this one, we have this. Okay, one more time. Here, negative 2 shift, and here, let's start it, right? Started. Let me make it more look like a dotted. Okay, dotted. So supposed to be like that, and then make it upside down, become this way, right? And when it's negative 3, it becomes that way. Okay, so let me erase the dotted part. Erase the dotted part. Oh, it's harder to erase the dotted parts. Make a graph easier to read. This one. So did I choose right? Sometimes I make a mistake on the test, on my own test. Let me see. So, oh, and I think I forgot there's one more here. Right? And the blue color, I need to get it. There's a parent function. So, okay. And one more. This one. Looks like that. Which one looks like this? Okay, let me see. This one? Looks like yes, right? I did right? Okay, yes. So I choose this one. This one. Oh. So I choose this one. Okay, so because let me make a screen smaller, probably we can see better. Do you believe I did the right thing. Yes, did I do right? Okay, okay. So you can go home, graph slowly. Is this one? Looks like yes, right? A little bit different here. Let me see. Here. More. This part. Later. I think I did right. Just more detail. Let me see. Anyone? Yeah. Okay. These little parts. Why is not coming? When this go up, down, this one goes to here. Oh, okay. Yeah. I think I did this one. This two. Okay. So when it's upside down, so originally we have that, right? This one will go to here. Yes, yes, because upside down, right? Positive become negative, negative become positive. And when we have this one become here. Yeah, that's right. Okay. So then, yes. So a little earlier, I made a little mistake here when I try to graph negative. Okay. Now the rest is the right one. This is not the right one. It's not right. Okay. So it means what I made the mistake is originally like this, right? And this part not here, because when we do upside down, this part will be there. Okay, let me graph. This part will be here, not here. That's not right. Okay. So I made a little mistake earlier around here. Okay. Okay. So any question? Oh, I forgot. We are not in the class right now, so no one can answer me. That's fine. Let's keep going. If you still have question, you may ask me during the class time. Okay. Now, let me stop the video right now because it's already take too long, almost 40 minutes. So next video, I'm going to start from number 3. Okay, bye bye. See you next time.